Hey everyone. So today begins trig, and what I want to do to begin trig is try and approach it from um, some things that you already know, some things that you should be comfortable with from junior high. Again, it'll be kind of a lesson where we can make sure we're all on the same page together before we continue on our little journey. Trig is really fun. And once you understand it, students do very, very well in grade 10 trig. Grade 12 trig can get kind of complicated, but grade 10 trig, once you grasp the concept, it's very repetitive. So because of that, kids tend to do really well with it because once they know what to do, they just keep doing it for every question. Okay, but you're going to have to give yourself some time to develop a good understanding of it before you're going to feel like it's easy. Okay, so I said I wanted to start you off with some things that you were familiar with. So my first question to you is, what do you remember about the Pythagorean theorem? Now, I'm hoping you would be comfortable to say, oh, well, Hill, it's c squared equals a squared plus b squared. Now, that is absolutely true. It is c squared equals a squared plus b squared. I have a problem with this, though, and the problem that I have with this is you have to know some parameters around what c is, okay? Who you're calling A and B doesn't matter, but you must call C the hypotenuse. The reason that's super important is because what if in a triangle I labeled something like this, where here's a right angle, and I said this was A, this was B, this was C. Well, now the Pythagorean theorem is A squared equals B squared plus C squared, okay? It doesn't matter what the letters are. What matters is it's always going to be the square of the hypotenuse equals the square of the two legs added together, okay? The non-hypotenuse is called legs of the triangle here, okay? All right, so find the length of the missing sides of the triangle to the nearest tenth of a unit. So you always want to ask yourself, do I have the hypotenuse or am I solving for the hypotenuse? In this particular example, you are solving for the hypotenuse. So you'll go a squared equals 11 squared plus 19 squared. And then you square the 19 and the 11. So that gives me a squared equals 482 when I add them together. Then you're going to take the square root, okay? When you take the square root, rounding to the nearest tenth, it's 22.0. Now, couple of things. There are lots of little tiny things here where you'll lose points. And in a nice mark boosting unit like trig is, you want to be careful that you communicate really clearly so you don't lose silly points, okay? First of all, lots of kids might look at this and say, why didn't you just write 22? And the answer is I had to round to the nearest tenth. That was what my rounding directions were. And so I have to have the 0 there because I have to have a tenth represented, okay? If I just said 22, that would be rounding to the nearest whole number, not rounding to the nearest tenth. So 22.0 refers to the specificity of my measurement. The other thing you must always have is your units. If you don't have units, I dock half a mark off right away. And those half marks can add up really quick. So you want to be careful that you're communicating super nicely, okay? Try this one. So now you want to ask yourself, do I have the hypotenuse or am I solving for the hypotenuse? In this one, you have the hypotenuse. The hypotenuse here is 12. So you're going to go 12 squared equals 2 squared plus b squared. 12 squared is 144, 2 squared is 4. So now I got to do some algebra here. I'm going to subtract 4 from both sides, so I get b squared by itself. And then I need to square root and follow the rounding directions. I end up with 11.8 inches. Okay, 11.8 inches. All right, Thales and around, or Thales, sorry. I actually, before I started this slide, I thought to myself, I need to hear how this is properly pronounced. It's Thales, I looked it up. So this dude named Thales in 7th century BC is the first person identified as a mathematician in his lifetime. He visited Babylon and Egypt to further his studies. While in Egypt, he asked the locals how tall the Great Pyramid at Gaza was, and he was astonished when no one knew. He then proceeded to make a series of simple measurements, including his staff and its shadow, to make an indirect measurement about the pyramid's height. How did he do it? Well, what can you do with your staff and your shadow, or its shadow, Well, here's its staff, his staff, and here's his shadow. And if I think about that, that forms a little triangle, okay? Well, then if I think about the pyramid, here's the height of the pyramid. And wouldn't the pyramid also cast a shadow? So here's the pyramid shadow. And really, how he did it was he created, or he set up a proportion based on what we would now call similar triangles, okay? These triangles have the same angle because they both have a right angle here, and this is at the same time of the day, so the sun's rays are hitting both of these objects the same way, okay? So that means these angles are the same and these angles are the same. And when we have similar triangles, the sides are in proportion to each other. So the proportion that I would create by going staff divided by shadow, okay, we'd call that some sort of a ratio, okay? The staff over shadow creates a ratio. The height over the shadow creates a ratio, okay? Those ratios have to be the same because the triangles are similar. So what a proportion is it's a ratio equals a ratio. It's a fraction equals a fraction, okay? And so if I know 3 of these things and I set it up, 3 over 4 equals x over 8, well, you have the ability to algebraically figure out what your missing value is. So that's what he did with the pyramids, okay? He figured out his staff and he figures out his shadow, and then he figured out the pyramid shadow, and, sorry, I said his shadow. I should have said his staff's shadow, just to clarify. I don't want to confuse anybody. Then he figured out the pyramid shadow, and he used this concept of a proportion to solve for the height of the pyramid, okay? So that is what we know. My next question is, what do you know about similar triangles? But that is what we know. When we have similar triangles are 2 triangles that are essentially enlargements or reductions of each other. Their angles have to be the same, and then their sides, their corresponding sides, are in proportion to each other, okay? All right, so if I asked you to find the length of y, given that XYZ is similar, triangle XYZ is similar to triangle DEF. There's a couple things I want to talk to you about as we start this kind of process. Number 1, the letters here always correspond to the exact same order of letters here. So I know that X and D are the same angle, I know that Y and E are the same angle, and I know that Z and F are the same angle, okay? I know that side XY corresponds to side DE. I know that side XZ corresponds to DF, and I know that side YZ would have to correspond to side EF. Okay, so just based on the way they've written this, I can figure all those things out if I'm unsure. Okay, so now I need to set up a proportion. Okay, so we got to get a couple ratios. I've got the base here and the base here. I'm looking at the hypotenuse here and the hypotenuse here. So that's how I'm going to set up my proportion. It doesn't really matter how you set it up. There's a bunch of different ways. What you can't do is you can't change the order. So I could go y over 6 equals 20 over 8. I went little hypotenuse over little base equals big hypotenuse over big base. Okay, that's one way I could do it. I could go 6 over 8 equals y over 12. I went little base over big base equals little hypotenuse over big hypotenuse. Okay, totally fine. They will all arrive at the same answer. What you can't do is switch direction. So I can't say y over 6 equals 8 over 20. Do you see what I did there? I switched the direction. You can't do that. As long as you don't switch the direction, you'll be fine. Okay, so we're looking at, I happen to set it up as 6 over y, so I went little base over little hypotenuse equals big base over big hypotenuse. And now we're going to essentially cross multiply here. We want to get rid of a division of y, so we multiply both sides by y, and we want to get rid of a division of 20, so we multiply both sides by 20. What that happens is we get 120 equals 8y, and then if I want y by itself, I just divide both sides by 8. And that gives me y equals 15 centimeters. Okay, don't forget about your units. Those are super important. All right, good. So a flagpole casts a 12-meter long shadow. At the same time, a person who is 1.6 meters tall casts a 0.96 meter shadow. Find the height of the flagpole. When you're given a question like this, the very first thing you should do is start drawing a picture. You need to visually see what's going on, and you need to label things so that you know where to go. So here's my picture. I end up with a flagpole and a person. I know the flagpole casts a shadow that's 12 meters long. Do you want to know one of the biggest mistakes I see kids make here? Is they put the 12 here. They think the 12 is the hypotenuse. When have you ever seen a shadow floating along the sky? Right? Never. I'm hoping, unless you see a ghost maybe. Shadows are on the floor. They're always on the ground, okay? So I've labeled the things that I know here. I know that the flagpole shadow is 12. I know that the student here is 1.6 meters high, and I know that her shadow is 0.96 meters in length. Okay, so now I'm looking for this guy here. I'm looking for the height of the flagpole. So that's enough to set up a proportion. The one I chose to do was I went base over height of my flagpole triangle equals base over height of my person triangle. Okay, so then I'm going to cross multiply, and I get 19.2 equals 0.96x. Then I'll divide both sides by 0.96 to get x all by itself, and the flagpole has to be 20 meters high. All right? Good. Okay, determine EC, which is this guy right here. That means going from E to C, we're looking for this guy, okay? So what you have to be careful of here is you have to make sure you're looking for similar triangles. So I've got a triangle here, okay? But then this EC is actually not part of another triangle. It's a piece of a side of another triangle. The other triangle is actually this whole thing here. You end up with a triangle inside a triangle, okay? So where this height is 4, this height is 10. You see that? Okay, so when I go to set this up, I got to be really careful about that. So I've said 4 over 10, so I went little side to big side equals little side to big side. So what I did was I called this x, and so this would be 8, and then the whole thing would be 8 plus x. That's where that 8 plus x here is coming from. That's the big length, okay? So I'm back to what I was doing though. I'm just gonna algebraically solve this. I'm gonna multiply both sides by 10. I'm gonna multiply both sides by 8 plus x so that I get rid of those denominators. If you understand that as cross multiplication, that's totally fine as well. 4 times 8 plus x equals 80. Now, you can either distribute the 4 in, or you could just divide both sides by 4 and then subtract 8, however you want to do it. I distributed the 4. Now I'm going to subtract 32 and divide by the 4, and I get x equals 12. Okay, x equals 12. I don't need units here because units weren't given to me in the question. Okay, so just some quick definitions that I would expect you are familiar with at this stage of your life. The word trigonometry refers to just triangle measurement. Okay, triangles share properties that allow us to solve for unknown lengths or angle measures. Similar triangles have corresponding angles that are the same, and sides are in proportion to each other, corresponding sides. They're essentially enlargements or reductions of one another. An acute angle is less than 90 degrees. An obtuse angle is between 90 and 180. A right angle is 90, just while we're throwing out angle vocabulary. 180 is a straight angle because it makes a straight line. And then if I'm beyond 180, if I'm 180 to 360, sorry, if I'm greater than 180 and less than 360, I'm called a reflex angle. The sum of angles in a triangle is always 180 degrees. And a right triangle is a triangle that has one 90-degree angle. What do you call a triangle that has two 90-degree angles? Not a triangle. All right. Now, I want to take some time to deal with how we label triangles, okay? So I have labeled this triangle with capital A, capital B, capital C. And so we would say this is triangle ABC, okay? I've also stuck this little symbol here. That little symbol is called theta, okay? It's a Greek letter. It's where our letter T comes from, but it's called theta, and it's often used just as a symbol to represent an unknown angle, okay? We often use the letter X to represent unknown lengths, and sometimes we still use the letter X to represent unknown angles, but theta is also used to represent an unknown angle, okay? Now, that's how you spell theta. So a couple of things I want to talk to you about. First of all, we can label each one of these sides. Now in junior high, you might be used to saying, like if I was looking at this side here, you might call that side BC because it's the side going from point B to point C. Okay, and that's cool, but we often don't want to deal with multiple letters when they refer to one item, because in math, if we see BC, we might think that's like a variable B times a variable C, and so we don't want to, we just want to avoid confusion. So what we do is opposite the angle, so this would be angle A, this would be angle B, and this would be angle C. Opposite the angle is the same letter, but lowercase. Now, when I say opposite, hopefully you can see my pencil here. We're going to put our pencil right in the angle, and we're going to go away from it. Okay, so opposite A would be little a. Opposite C would be little c. And opposite B, I'm just drawing away, and it will always point to the side I'm talking about, is little b. Okay, so you need to be able to be comfortable labeling the triangles with the letters. As well, we have words for these. Okay, now this side you already know, it's the hypotenuse, and you already know that from your work with the Pythagorean theorem. Okay. This side we label as the opposite. Now I need to make this very, very clear. That word opposite is because it's opposite the angle that we're looking at. Theta was right here. So that represents, this is the angle I'm staring at right now. And so opposite that angle, we're going to call that side the opposite side. Okay. Then this guy's the hypotenuse. We've already talked about that. And then this guy is called the adjacent. Okay. Adjacent means the side or touching. So we can call this guy C because he's opposite C, and we can call him the opposite because he's opposite theta. We can call this guy B because he's opposite angle B, or we could call him the adjacent because he's adjacent to theta. And then this guy we can call A because he's opposite angle A, or we call him the hypotenuse because he's opposite the 90-degree angle. Okay? If, remember that I said theta was here right now. If I put theta here, sorry, I was just trying to switch colors. If I put theta here, then this is no longer the opposite. This is no longer the adjacent. This would be the opposite, and this would be the adjacent. So depending on where I put theta, it will flip who the opposite and who the adjacent sides are, but the hypotenuse will stay the same. The hypotenuse always stays there, okay? All right, good. Now, if we were in class together, we would walk through this triangle investigation. And I'm just going to quickly show you kind of what I would want you to have seen. Okay. I gave you a bunch of different triangles. So I'm just going to make two random for a second. And we're going to say that those are our two triangles. Okay, and I'm going to say that I have a 75-degree angle here. And I have a 75-degree angle here. Okay, can you guys see that? Okay, yeah. Okay. Now, the first thing I would want us to do is I'd want to label who the opposite, who the adjacent, and who the hypotenuse is. Okay, well, if that's my 75 degrees, that's the angle that I'm looking at. So I point my pencil away from there, and that would point to the opposite. Opposite 90 degrees is always the hypotenuse. And then the other guy is adjacent. Adjacent is part of the thing that makes the 75 degrees, but it's not the hypotenuse. Okay, it's always the hypotenuse and the adjacent that come together to make the angle that we're looking at. Okay, and then this guy, the 75 degrees is here. So if I point away from the 75 degrees, it will point to my opposite. My hypotenuse would be opposite the 90-degree angle. And then the other guy is the adjacent. Okay? Then I said, measure the lengths of the opposite sides and the adjacent sides. Now, here's what I want you to understand. I could get out a ruler and measure this length and measure this length. Okay? That's totally fine. And then I could get out a ruler and measure this length and measure this length. Okay? Now, I want you to notice what my next direction is. For each of the triangles, find the ratio of the opposite side divided by the adjacent side. So if I took this opposite and divided by this, I'm going to get 1.73. If I took this opposite and divided by this, I'm going to get 1.73. Okay? And then that would make you really excited if you were in my class doing this with me right now. And be like, why are we getting the same answer? Well, we should be getting the same answer. Think about it for a sec. If this is 90 degrees and this is 75 degrees, we already know what this guy is, right? Because all the angles in a triangle have to add up to 180. And so we know that we have similar triangles here. And we know that opposite and opposite would have to be corresponding sides. And we know that adjacent and adjacent would have to be corresponding sides. So if I take the opposite and divide by the adjacent, I would get a ratio that I would always end up getting if I took the opposite and divided by the adjacent for similar triangles. Okay, they always end up being the exact same thing. So all the ratios, sorry, it's 3.7. It's not 1.73. I just made that up off the top of my head. 3.7, 3.7. I wasn't thinking about the right number in my head. Okay, all the ratios turn out to be around 3.7. Actually, exactly 3.7, but we'll talk about that in a second. Okay, does this make sense? What do you know about all of the triangles you were working with in that investigation? They were all similar. That's what we were just talking about. Okay, all the triangles are similar, so it makes sense that the ratio of two pairs of corresponding sides ends up being the same thing. Okay, it's all based on the fact that those triangles were similar. Okay, now there's a word for that particular ratio. If the ratio is never going to change, let's put a label on it and use it with other triangles. In fact, this ratio is known as the tangent ratio. The tangent ratio is the length of the opposite divided by the length of the adjacent. Okay, now we can check this in our calculator. Let's see what our calculator says about the tan of 75. Now, before you go do that, we need to have a quick little conversation about your calculator. There are two different ways to measure angles. Okay, one is called degrees and one is called radians. Now, in senior high, for those of you who have graphing calculators, this is really important because your graphing calculator by default is not in degree mode, it's going to be in radian mode. Every time you reset your calculator for a test, it will bump you back into radian mode, so you have to know how to switch the mode of your calculator. If you are a child of Casio, okay, you are going to, when you're in your calculator screen, you are going to press Shift Setup to go into the menu, or Shift Menu to go into the Setup feature, and then you'll notice right at the bottom of your screen, it says degree, or it says angle, and then F1 is for degree and F2 is for radian. So you just press F1 to put yourself in degree, and then you exit out of there. If you are a child of TI, you will press the mode button, which you find right to the right of your second function button. That's the colorful one, depending on what model you have. And then you go down 3 and over 1 so that you're on the word degree, and hit enter when you're on the word degree, and you'll notice that degree becomes highlighted. And then you know you're in degree mode, so you can just exit out of there. Okay, so if you were lost on what I just said, These are the instructions for Casio, and these are the instructions for TI. And then you'll notice that the tan of 75, you get 3.73, okay? So if we were doing this investigation, and you actually measured the opposite, and you actually measured the adjacent, and you divided them, it would always give you 3.7. In fact, it would give you 3.732050808. Okay, it's an irrational number that goes on forever. But it represents the ratio that must be there if I have a 75-degree angle and I want to take the opposite and divide it by the adjacent. Okay? It is super important to realize what happens when you press tan 75 in your calculator. When you press tan 75 in your calculator isn't calculating anything. It's just retrieving information. That 3.73 is never going to change. If I have a 75-degree angle, the opposite divided by the adjacent always has to give me this, or I can't form an angle. It's just not possible. That won't close together. Okay. Now, obviously, that number is going to change if the angle changes. Okay. But for every angle, there is a specific number that represents the ratio of the opposite over the adjacent. So essentially, when I was little, we looked all those up on tables. Okay, we just said, okay, I have a 75-degree angle. What's the tan of that 75-degree angle? And we would have just read it off the table. And then we got this notion, hey, let's store all that information on buttons on our calculator so that we don't have to carry around tables anymore. So it's just information that's stored in your calculator. Okay. All right, so given the following triangle, determine the ratio for tan B and tan C. Well, tan B, that means I'm looking at angle B. So when it says tan B, I'm looking at angle B, and I want angle B's opposite divided by its adjacent, which happens to be the 12 here. So opposite divided by adjacent would be 6 divided by 12. So tan B is 6 over 12, and then I just reduce that to 1 over 2. So the ratio for tan B is 1 over 2. Okay? What if I asked you for tan of C? Well, that means if I'm looking at tan C, I'm looking at angle C. So now I'm looking at angle C's opposite divided by angle C's adjacent. Do you see how these guys flipped positions? Because I flipped the angle. So tan C is actually now going to be 12 over 6. Sorry, I got lost in my ink annotation there. Okay, so 12 over 6, and then that I could just reduce that. 12 divided by 6 is 2. So tan of C is 2. All right, using your calculator, determine the following ratios, correct to the 4th decimal place. Explain what each of the ratios mean. So all you're doing here is you're physically typing in your calculator, tan 60, enter. And you get, when properly rounded, that's what I was thinking about when I wrote the 1.73. I knew the 1.73 was coming up. Sorry about that. So tan of 60 is 1.7321. Tan of 25 is 0.4663. Okay. And again, all I'm doing is going tan of 60, enter, tan of 25, enter. Okay. What do they mean? Here's what they mean, and here's what I really want you to understand. The math that we have to do once I get you to understand this stuff is really not hard, okay? I just really want you to have a good understanding of why you're doing the math. If I have a right triangle with a 60-degree angle, the side opposite that angle divided by the side adjacent to that angle has to give me 1.73, or a triangle wouldn't be able to be formed, okay? All right, so that's where I'm gonna leave it for this first lesson. Tomorrow, we're gonna dive into, there are actually 6 different ratios. I just introduced the concept with one ratio, but we'll look at all 6 for a brief second, and then we'll look at what we can actually do with those ratios, okay? In the meantime, you have homework to do, and if you have any questions, please connect with me, okay? Have a great day, guys. Bye-bye.